Have you ever faced a situation where your application just doesn't behave as expected? It's frustrating, right? If you're deploying a Flask app using uWSGI and running into issues with signal handling, you're in the right place. Today, we're diving into how to effectively use uWSGI's signal framework to update caches across all workers. I completely understand your concern. When you're relying on in-memory dictionaries for caching, it can be incredibly annoying when signals don't propagate as they should. You're definitely not alone in this struggle. Many developers face similar challenges. Let's look at the specific situation you're dealing with. You mentioned that you have a Flask app running in a Docker container with 4 workers, and you're trying to update cached values across all of them using uWSGI's signal framework. But despite targeting all workers, the signal seems to only reach one. Sound familiar? Let's explore this together. So what could be going wrong here? It seems like the signal is not being broadcasted to all workers as intended. This can happen due to how signals are registered and triggered in uWSGI. We'll break down the steps to ensure that your signals reach every worker. And stick around. By the end of this video, I will share a crucial tip that can help you avoid similar issues in the future. To address the issue of signals not reaching all workers, the user should first ensure that the signal handler function is correctly defined. This function will be responsible for updating the in-memory dictionaries across all workers. Next, the user needs to register this function as a signal handler for all workers. This is done by using the register signal method with the target set to workers. After registering the signal, the user can trigger it whenever an update is needed. This will send the signal to all workers, allowing them to execute the update function. If the user still encounters issues with signals being handled by only one worker, they should check the uWSGI configuration to ensure that the Lazy Apps option is enabled. This allows each worker to load the application independently. Finally, the user should monitor the application logs to verify that the signals are being received and handled correctly by all workers. This will help in troubleshooting any further issues. Fun fact: did you know that the uWSGI project was started to help developers manage their Python applications more efficiently? It's a powerful tool, but like any tool, it requires the right techniques to use effectively. Now let's look at the answers provided by other users. An alternative solution from another user suggests changing the signal target from workers to active workers. This adjustment helps prevent overflow in the signaling queue when non-active workers are signaled. They also note that using lazy apps can lead to multiple signal registrations in workers. That's the end of that answer. Let's see another perspective. An alternative approach suggested by another user is to utilize uWSGI's caching framework instead of relying solely on the signal framework. They point out that uWSGI does not provide robust internal data exchange mechanisms and recommend checking the caching documentation for potential solutions. Here's the tip I promised: always test your signal handling in a controlled environment before deploying. This can save you a lot of headaches down the line. And there you have it. With these strategies, you should be able to effectively manage signals across all your uWSGI workers. If you found this video helpful, please hit the subscribe button for more tips, and don't forget to share your experiences in the comments.